Hello, guys. Welcome back. I am here with a new video, and in this video, I'll be explaining chemical weathering. Now, in the previous video I uploaded, I explained the physical aspect of weathering, which includes pressure release, um, frost shattering, and temperature change. So now I'll be going through chemical weathering. Now chemical weathering it occurs rapidly, normally in hot and wet climates, such as those in the Caribbean. Right? So during chemical weathering, we could say that the rock decomposes. Now when we say the rock decomposes, we mean that the chemical structure of the rock is affected, right? So meaning that the rock, would be useless. So I'm gonna be starting off with carbonation. Now there are three main types of weathering. We have carbonation, we have oxidation, and we have solution. Carbonation, oxidation, solution. First thing, let's look at carbonation. Now, this is the most important form of chemical weathering. These normally occur in limestone areas such as Jamaica, right? So, well, not really Jamaica, but an example would be Jamaica, right? So, whether you have a tropical or temperate zone in the earth or in the world, these areas that have limestone would be affected by carbonation. So Jamaica, right, is affected largely by carbonation, right? So what happens during carbonation is that rainwater absorbs carbon dioxide from the air. Now, carbon dioxide is one of the gases that is in the Earth's atmosphere, right? So when rainwater absorbs carbon dioxide in the atmosphere, we could say that it produces a weak carbonic acid. So let me write my equation right now. So I'll be putting in, okay. All right, let me just write it. Okay, so this is the equation. We have H2O, which is water. This would be rainwater, plus carbon dioxide, which is CO2. And it produces the mild carbonic acid, which is H2CO3. H2CO3, right? So this is the mild carbonic acid. Now, with this mild carbonic acid, it would set on the calcium carbonate in the limestone, or we could say that it would react. So, H2 H2CO3, which is the mild carbonic acid, it would react with the calcium carbonate that is present within limestone rocks. Have it right here, CaCO3. And this calcium carbonate component in the limestone, we are going to say that it is insoluble. So when those two react, it produces calcium bicarbonate. me erase that right there, is Ca. It is Ca bracket HCO3, and outside of the bracket you have 2. Right? So when it produces calcium bicarbonate, it becomes soluble. So when it becomes soluble, right, it is then absorbed by the water. When it is absorbed by the water, it's easily washed away. Now, most rain falling in these areas, it soaks into the ground and it results in pits and holes, and these are common in limestone areas, or you could say karst landforms, right? So the carbon dioxide, and not only carbon dioxide, can break down the limestone. You also have other sources of acids such as the nitrates and the sulfates, right? And these can also dissolve rainwater. You have also those industrial pollution, the things from the industrial pollution. These can also dissolve in rainwater, right? So the higher temperatures in the tropical areas, these normally increases the speed or the rate of carbonation. Now, chemical reactions normally occur faster in higher temperatures. Higher rainfall also increases the rate of weathering, right? So now we're going to look at oxidation. Now, the first thing, when we think about oxidation, we think about oxygen. Now, oxygen is another gas in the atmosphere. Now, this oxidation is the process, right, of the chemical addition of oxygen to compounds in the rock, right? So, normally oxidation occurs for rocks rich in iron, or those that are exposed in air or water. Now, let's say this rock has iron rich particles. Pretend that these are the iron rich particles, right? So these are iron rich particles, right? So when this reacts, the iron particles react with the oxygen in the air, the reaction forms ferric iron oxide, right? And this is hydrated. Now, the iron compounds, they are therefore affected, and a reddish brown discoloring of the rock occurs, which is also called rusting. So you can also think about the steel that they use for construction or the building of houses, right? The same way, let's say you put it outside for a while, right? And you realize that you see that reddish brown, right? Or that orangish color. That is oxidation taking place, oxidation of the steel, whereas the oxygen is reacting with the iron component in the steel. The same thing happens with rocks, right? So a thin soft crust is then created on the outer part of the rocks, which causes the rock to crumble. Now the ferrous iron oxide, FeO, right? It then reacts with the oxygen in the air. Now, this is the equation for the process of oxidation. Now, this oxygen in the air is normally in the presence of water. And when ferrous iron oxide reacts with the oxygen in the presence of water, it produces produces ferric iron oxide, Fe2O3, right? And in order to balance the equation, we put the 4 right here, and we put a 2 right here. Now, this is explanation for oxidation. Now it's on to the next process, which we call solution, right? Now, when solution occurs, right, various rocks have salts or various minerals such as sodium and potassium. Now, sodium, potassium are soluble, right, in water, especially if the water is acidic. Now, the greater the acidity, which would be the lower the pH, then the more soluble the minerals become. Now, the rainwater falling on rocks containing the mixture of different minerals can be weathered, right? So some of the minerals that are in the rock, they are dissolved. So when those minerals in the rocks or when are dissolved, or when the rainwater, right, dissolves the minerals in the rock, it leaves the rock structure weaker, right? So let's contrast it, or let's compare it, let's compare it to a potato, right? Now, normally people cook or boil potatoes with salt water. Now, let's look at it. Pretend as if salt is contained in the potato, right? So what happens is that the salts are then dissolved by the water, and then it would allow the structure to be of the potato to become weaker, which would then cause the potato to become flaccid, right? So you can also use that to help you remember. So that's the same thing with solution, right? So this is the end of our video. Like, subscribe, and share. And in the next video, we'll be talking about biotic weathering.